In an earlier video on if statements, we created a very simple guessing game. The player had to guess a number between 1 and 10. We want to open up that guessinggame.py file and work on that in this video. Now what I'm going to do is delete the commented out code at the end because we no longer need that. Alright, so there's our code at the moment. Now, as it stands, there's a number of problems with this game. One problem is that it only allows 2 guesses. If we wanted to allow more than 2 guesses, we'd have to nest more and more if tests every time the player guessed incorrectly. The other problem is that 5 is always the correct number, which makes the game a bit boring, not that it was terribly engaging to begin with. Now, the first problem can be solved using a while loop, which is what you'll be doing in the challenge coming up next. Before we do that though, let's digress slightly and address the second problem so that we can produce a more interesting game. To fix the problem of the correct number always being 5, we need to get the computer to generate a random number in the chosen range. That's 1 to 10 in the example, but we can extend that. Python has a lot of features built in, such as the ability to do arithmetic, lists, ranges and tuples, and more. There's enough built in fact, for us to be able to write a random number generator if we wanted to do that. The good news is though, however, one has been written for us and comes included with Python in a module called random. We'll be looking at creating modules and packages much later in the course, but for now what we're going to do is use the random generator that comes with Python. Because it's in an external module, we need to import it into our program to use it using an import statement. When you want to use objects from the Python standard library, you import them, usually at the start of your program. Importing a module allows you to use all the objects from that module in your own code. So we want to use the randint function from the random module, so we can start by importing random. We're going to do that right up on line 1 by typing import random. Now that we've imported the module, we can use its randint function on line 3. So let's change the 5, the literal value 5, to random dot randint parentheses 1, 10. I've used random.randint on line 3 because the randint function is in the random module. We imported random on line 1 at the start of the program, and we can now use the functions it contains by using what's called dot notation. We separate the module name from the function name with a period or dot, which is why it's called dot notation. We're using dot notation to tell Python that the randint function is found in the random module. The randint function produces a random number within the range we specify. We've passed the values 1 to 10 to the function, which means we'll get a random number from 1 to 10 inclusive. So we've used the value 10 in 2 places in our code. If we wanted to increase the range of numbers that the player has to guess, we'd have to make a change in both of these places. That's a good way to introduce bugs in your code. So if we change the value on line 3 but forgot to change the message on line 5, the program wouldn't behave as the player would expect it to. We can make the code more robust by using a variable to store the upper value. So let's have a go at doing that. So on line 3, I'm going to type highest is equal to 10. Then on line 4, I'm going to change the literal value 10 to highest, like so. And then what we're going to do is change our message here, delete 10, and put left to right curly braces instead, and after the double quote, put dot format, and in parentheses, highest. Now we can increase the range if we wanted to by making a single change on line 3, and the change would be reflected in both places. Right, so let's run the program and see if we can guess the number. So I'm going to guess 5 the first time. And if that's too low, I'm going to guess 8, otherwise I'm going to guess 3, unless 5 happens to be correct, of course. So let's try 5. And I got it first time. Amazing. It is actually quite hard to test this program properly, unless we're really lucky. We can't test that it prints the right message when we guess correctly. But of course I got it correctly the first time, so let's try running it again. I'll try 5 again. Please guess higher. This time I'm going to guess 8, as I mentioned I would do if it was too low. And well done, I guessed it. Well, I'm having an amazing amount of luck here because this is entirely random. We'll try one more time. We'll try 5 again. And that's just, again, amazing. 3 times out of 3. Please guess higher. We'll try 8 again. This time, finally, we've got it wrong. Sorry, you have not guessed correctly. I'll try one more time just to see if we can get the opposite to happen. 5 again. Please guess lower this time. I'm going to try 3. Well done, you guessed it. Again, I'm having an amazing run of luck here. One more time. I can't believe I've got this right so many times, but we'll try one more time. Please guess higher. I'll try 8, and we'll leave it at that. So we didn't get to see us not getting it correctly by guessing a lower one, but that's fine. That really alludes to the fact that it is quite hard to test the program properly, because even if it does print the message, we can't tell if it should because we've got no idea of what the correct answer is. So to get around that while testing, what we can do is print the value of answer out. So for testing purposes, it just makes it easier for us to know rather than just guessing. So what I'm going to do is add the code. On line 5, I'm going to do print answer. That's going to be the answer from the, so that's basically the number that's been randomly generated. I'm also going to put a comment here, hash to do remove after testing. Obviously, you wouldn't want to leave this in a real game because, of course, what would happen would be the player would know the number to guess each time. Now, you might be wondering what happened with that to do. 2 things. Firstly, it changed to blue when I typed to do. But secondly, IntelliJ treats comments that start with to do in a special way. It highlights them in blue with my color scheme and also keeps track of them. Down at the bottom of the screen, we've got a to do tab. I'm going to come down here and click on that. If we open that up, we can see that it'll give us a list of all the to-dos, in this case just in the one file we've got, and it actually tells us even that on line 5 we've got print answer and it shows us the to-do that I've actually entered. So you can basically expand the sections and double click on a particular entry to go straight to that line in your code. So for example, if I was down there, double click it, my cursor moves back up to line 5. Very useful if you happen to be in another file at the time. So in general, to-dos are a great way to keep track of things so that you don't forget about changes you intended to make. Note that this is a feature of IntelliJ, the IDE. It's not a Python feature. Python just treats that comment like any other. Alright, so at this point now, the program should be easy to test, even though I had a good run of luck last time. I'll just close down the to-do tab. Let's run it again. And what I can do is check what happens if I get the correct result first time and on my second guess. So the first time, we know that the value is 1 there. So if I enter 1, we got it first time, so we know that that's working. We'll try it again. This time I'll enter a number that I know is too high, 8. Please guess lower. Well, I could guess 5, guessing the number correctly on the second time. Well done, you've guessed it. And obviously, now that you know the number, you can go through all the different scenarios of testing to make sure you fully test all program flow conditions. So at this point, you'll probably find the program a bit frustrating. With 10 numbers to choose from, you'd probably need a minimum of 4 guesses to be sure of getting the number if you didn't know the answer in advance. And that sounds like a good challenge to try. So the challenge is to modify the program to use a while loop to allow the player to keep guessing. The program should let the player know whether to guess higher or lower and should print a message when the guess is correct. Now it already does that, but I suggest you don't worry about printing a different message if they get the correct answer on their first guess. We'll look at counting the number of guesses later. A correct guess will terminate the program. Now as an optional extra, allow the player to quit by entering 0 for their guess. So these challenges are intended to give you a chance to practice what you've learnt. Don't think of them as tests. There's no pass or fail as such. If you have a go but don't manage to solve the entire challenge or even part of it, that's fine. Generally, most people, even if they don't successfully complete it, will learn something from the experience, so it's well worth giving it a go. The bottom line is you'll learn a lot more by trying before you watch my solution coming up in the next video than you would if I just presented you with the working code. So have a go and see how you go with it, and we'll go over that solution together in the next video.